Welcome back, fellow nerds. We're back to another example on motion, and it reads: two dogs, Tonny and Goosy, spy a bone and decide to go for it simultaneously at t is equal to 0. Tonny is 15 meters to the left. All right, so let's assume. So with physics, we said you have to assume this is your bone, okay? And there is one dog there and one other dog here, right? Well, I'm not an artist. So you have Tonny and Goosey, right? Tonny is 15 meters to the left, right? So this is your right. This is, in fact, on your number line, that is your right, where you have your positive, right? And this is your left, where you have your negative, right? Okay, so all right, so on your left you have your negative and on your right you have a positive. However, according to picture formation, right, where you, as you look at it in front of you, your right hand on paper is your left side, right? But then there's a specification. They have specified to say Tonny is 15 meters to the left, where at x is equal to negative 15, which means your left is the part holding the negative sign and the other part 20 meters to the right, where x is positive 20 is on your right. Okay, so on your right you have 20 meters and on your left you have 15 meters, which is negative 15. Then you have 0, that is why you have your bone at, right? Simultaneously at time equals 0, the both dogs actually start to head that direction to the bone, right? The resulting velocity time graph for the two dogs are shown in the figure, right? So the question is, from the graph, identify the lines representing the motion of Tonny and that of Goose. Explain your response. All right, so which one is Goosey and which one is Tonny? Okay, so when we look at the graph, the line 1 shows a velocity moving from 0 to negative 15, right? Because this section is in the negative y-axis. All right, what does that entail? It entails you are decreasing your velocity, right? Because 0 is greater than negative 15, which means you are decreasing, or rather moving in the opposite direction in that case, because you are moving below a positive 0. Okay, so if you are decreasing your velocity, and we know velocity is change in displacement with relative to time, right? Which of the dogs is reducing velocity? Now, according to math, you would discover that if your your numerator, sorry, is decreasing, your whole value on the other end is decreasing, right? So if your value is decreasing, it denotes that this value on top is doing what? Is decreasing. Your displacement is decreasing, right? And if you look at the two, this is Goosey, right? This is Goosey, this is Tonny, right? Okay, right. So Goosey looks like is moving from a positive 20 heading to 0, right? Which means its displacement, its distance is going is reducing to that degree. And if your displacement is reducing from your final heading to 0, whereas your initial was 20, and 0 being a lesser value as compared to 20, which means your displacement is reducing and hence your velocity is reducing. And so on your graph, the one that is going to denote a reduction in velocity would denote Goosey, right? And that is why Goosey will be line 1, right? Because it shows the slope is in a negative direction. The slope looks like it is going down, and as such it is decreasing velocity because he is moving from a positive direction heading to a negative direction, from a positive direction heading to a negative direction, and that is why Goosey will be line 1. And now, whereas for Tonny, since Tony will be moving from a negative direction heading to a positive direction, from negative 15 to 0, and because 0 is greater, which means he will be increasing his, so let's do this. So Tony is v is equal to distance over t. He will be increasing his displacement, and so will be his velocity, which means his velocity will be increasing, and that is why line 2 would denote Tony. And that is your explanation. Given Tony is moving from the negative to a positive direction, his velocity will be increasing, and like Goosey will be moving from a positive direction to a negative direction, his velocity will be decreasing, and that will be you identifying the lines representing Tony and Goosey and explaining your response. All right. Then for the next one, which of the two dogs got the bone? Show your working. All right. So if we're looking at the one that got the bone, we are looking at the one that reached the bone first, because they all started from time 0, and as such we are going to find out how long it took for each of the dogs to actually reach the bone. All right. Okay, and as such, to find our distance, we in a velocity time graph, we use the area beneath the curve, right? Because change in velocity is equal to change in displacement with time. So as you change your velocity, as you change your time, it shows you have moved a certain displacement, and as such we are going to use that concept to find our time. All right, and how do we do that? So for line 1, which denotes Goosey, right, we are going to say what is our area under the graph. You have those are triangle in shape. All right, so our area, which is going to be our distance, right, is going to denote what is our distance for line 1. Line 1 denotes Goosey, right, and as such 20 meters was the distance Goosey was at from the bone, right? Our base will denote time, which is t1, right, because that shows line 1. T1 multiplied by our height shows all right, our height shows 15. Okay, and that, so we are going to have 20 times 2, we are going to have 40 meters. T1 multiplied by 15, we'll have over 15. Over 15, we have T1 will be equal to 2.66, that will be 2.67 seconds. Okay, then let's see the time. Okay, again we do the same for Tony. Area is equal to half BH, and our area, which denotes the distance, which is 15, and our base, which is going to be T2, and our height is going to be 10. All right, so we are going to have our base, which is going to be T2. This is the time. Our height is going to be 10, okay, over 2, that will be T2, that will be 10 is equal to 15 times 2 is 30, divided by 10, that will give you T2 3 seconds. Okay, so you have Goosey taking 2.67 seconds, and you have Tony taking 3 seconds, right, to reach the bone. Which one reaches the bone first? The one that took less time, right? And so Goosey becomes your winner because he took 2.67 seconds. All right, okay, we go on to the next. Okay, the next question reads, at what position was the loser dog when the winner reached the position of the bone? Now we know the winner reached the position of the bone at what time? 2.67 seconds, right? All right, so we want to know at what position was the loser dog at 2.67, and as such we have to know at what velocity was the loser dog at 2.67. Now a specific time, finding a velocity at a specific time, that entails what we call instantaneous velocity, right? instantaneous velocity, right? That is just velocity at a specific time. So if you are told to find velocity at 2 seconds, the velocity immediately at 2 seconds, exactly at 2 seconds, will tell you instantaneous velocity, right? Because I'd explained earlier when we were talking about speed, because speed and velocity are magnitudes of the same. They only differ because velocity is a vector and speed is a scalar, and such. The same concept applies when we talk about instantaneous velocity, instantaneous speed. We're talking about speed or velocity at a specific time. All right, and that is what we're trying to find out. We're trying to find at what speed the loser dog was at 2.67, where the winner dog had actually won. All right, so we are going to find velocity at 2.67 seconds, right? And your distance, your displacement at 2.67 seconds. That is the question, the distance at which the loser dog is at 2.67 seconds. Now distance, we say velocity is equal to displacement over time, right? And as such, and since we are dealing with the graph, we are going to discover that area under the graph will be the distance, right? And our base will be the time, which we already know we're trying to look for the velocity at 2.6 seconds, the distance at 2.6 seconds, at 2.67 seconds. So we are going to say area is equal to half BH, right? Whereas our base, which is our time, in this case is 2.67 seconds, all right? Our height, which is going to be our velocity, which we do not know. Our area is what we are looking for, which is our distance at 2.67 seconds, all right? So we are going to first find our velocity at that time, right? Now if we are going to find velocity at 2.67 seconds, we are going to find that using one of the equations of motion, u plus at, right? Assuming the velocity that has been given in the question, 10 meters per second, to denote t2, which is 3 seconds, because t2 indicates the time spent for Tonny, right? That shows speed exactly at 3 seconds. And if we are going to, and since we have a line that is uniform, it denotes we have a constant acceleration, right? And as such, we are going to find that constant acceleration to help us find a velocity at whatever time we choose. And in this case, we are trying to find a velocity at 2.67 seconds. And in that case, we are first going to find our constant acceleration, right? A constant acceleration, which we know is acceleration, is v over time, right? A change in velocity over change in time. And we know our velocity is 10 meters per second and our time is 3 seconds. So our acceleration is going to be 10 divided by 3, that is going to be 3.33 meters per second squared, right? And having that acceleration, we can now find our velocity at the time given. So we're going to have velocity is equal to, we already know they had both started at t0, and at t0 indicates no motion took place, right? Which means we did not entirely have initial, because it was 0, there was no movement, there was literally nothing there. So we only have acceleration times time. So our velocity at that acceleration at 2.67 seconds will give us what? Will give us 3.33 multiplied by 2.67. 2.67 will give us 8.89 meters per second as our velocity at that time. And as such, we can now find our distance. Area is equal to half BH. We already found out that area will indicate our displacement, and B will indicate our time, which is 2.67 seconds, multiplied our height, which will be now 8.89 meters per second over 2. Now we have 8.89 multiplied by 2.67. That gives us that. 23.3, then divide by 2. That is going to give us what? 11.86. That will be 11.9 meters. That is going to be our distance, right? Our distance. Okay, now this is the distance it has moved in 2.67 seconds. Now we should remember that the Tony was coming from negative 15 meters, right? And so we have added an 11.9 meters which he has moved, and as such his original position will now be negative 15, which will be negative times positive. That gives you negative, right? So we are saying 15 minus 11.9, that gives you 3.1. You get the sign of the bigger number, which is a negative, and that will be negative 3.1 meters as Tony's position at 2.67 seconds. And okay, so that is about it. You find the area underneath the curve which would denote distance. Then you add that distance that has been moved to the original initial position where it was at, and that will give you negative 3.1 meters. Or you can say it is 3.1 meters to the left. Same response, same answer. So yes, I hope we meet in the next video, and I hope you've learned something.